Headlines on Mars. Perseverance converts CO2 in the atmosphere to oxygen. Ingenuity flies again, this time higher and longer. And space junk problem. 200 high-risk pieces identified just days after Crew 2's close encounter. It's the 17th week of 2021.
On Apple Podcast, Spotify, Google Podcasts, and YouTube. With the latest science and space news, this is Talkin Science with Dr. Brad Tucker and Matt Miller.
Welcome to Talkin Science. Matt Miller with you for another instalment of the Science and Space News. Dr. Brad Tucker is here. Brad, happy Tuesday.
Yeah, another Tuesday coming and going almost as fast as Mondays, but not quite.
Brad, very thrilled to have the support of Omnidesk for the new look Trekzone edit suite. And while I haven't got the RGB installed just yet, the desk is set up and giving me an awesome experience while editing. A huge thanks to the gang at Omnidesk for the support as we continue to bring you 7 podcasts a week in 2021. Well, before we get into the show, Brad, a quick reminder of the socials. We can find you on Twitter at btucker22. I'm on Twitter at Miramat86 and, of course, Trekzone exclusively on Twitter. Plus, find our YouTube channel for the latest eps and on your podcast app of choice. Brad, let's get into it. News just in ahead of our recording. Starship 15 has performed its first engine firing, a static test.
Yeah, so obviously, they're progressing well with their rockets. Hopefully when this one flies and launches, it will explode less than some of the previous. But look, they are landing or sticking to landings now, so it'll be exciting to see. Hopefully this one do it all.
Well, the International Space Station crew complement is now 11, and they've run out of beds. Thankfully, only for a couple more days when the 4-person Crew 1 disembarks.
Yeah, when you have these kind of like transition times, so we have one group arriving and the next group coming, it means that, you have 11, which is a record. 13 people have been in space, but in all of those cases, 7 were on the space shuttle, so there wasn't 11 on the space station. So 2 are having to camp out in the old Crew Dragon. Luckily in space, you literally can pinch a tent anywhere. You just get some Velcro in a sleeping bag and you're good to go.
Well, we're going to Mars for 2 of our stories this week, Brad. First up, the Perseverance rover. It's just made oxygen out of carbon dioxide on the red planet.
So this has been one of the exciting, there's lots of exciting instruments on Perseverance. This has been one of the, ones that it's been interesting to see what was going to happen. And obviously one of the first results out of Perseverance, and that is really converting carbon dioxide into oxygen, which is important for so many reasons. And it's exciting, I think, how quickly they got MOXIE, as the instrument's called, to work.
Absolutely. Well, it's MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment. We've talked about how acronyms are an astronomer's best friend, and space industry as well, no difference. Well, it produced 5.4 grams of oxygen after warming up for 2 hours. That's enough to supply an astronaut for 10 minutes. Small but important first steps, Brad.
Yeah, that's exactly right. It was only operating, it's only a toaster-sized thing as well, operating for a couple of hours, producing 10, 15 minutes worth of oxygen. Now, it's important because it worked, and obviously you always like things to work. Now, the technique it used, electrolysis, isn't groundbreaking. We've used these sorts of things before. It's the idea of using it on Mars, the way it was used. And really, this is the first time ever we've converted a natural resource on a different planet. And this is going to be a bigger part of the conversation and the work needed as we go further into space, albeit whether the moon or Mars or otherwise. And that's essentially living off the land. And this was that first step to doing so.
Yeah, well, the best part about this is that the Martian atmosphere is 96% CO2. So if they scale up MOXIE, much needed rocket fuel and breathable air won't need to be transported from Earth.
Yeah, that's exactly right. There's so much carbon dioxide on Mars. And now, obviously, plants are saying, hey, we've been doing this for billions of years. What's the big deal? But we can't obviously grow plants on Mars. And obviously, yes, maybe we can in contained bubbles or environments, and that may be a way further down the road. But as you said, we can't bring all of this stuff with us. whether for breathing or rocket fuel, as you said. And it's just too costly. I mean, even if at the lower rate of $20,000 per kilogram, well, 5 grams gave you 10 minutes. So you need roughly 30 grams to breathe for an hour. So you really are talking about you need a couple of 100 grams of oxygen per day to breathe. So if it's spending, $20,000 a kilogram, you're spending about $60,000 a week or so, maybe in oxygen. And, then the costs just start blowing out. It just becomes not economically or technologically feasible to bring everything with you, much like airplanes don't bring, for the most part, their fuel with them on the return journey. They land, they refuel, they come back. You don't bring all of your food with you on your holidays. You buy it there. This is essentially the exact same idea.
Well, Moxie has to get to 10 grams of oxygen per hour, so she's about a quarter of the way there already.
Yeah, that's right. It is chugging through, and it is working, and hopefully once it fully works, the mission is complete. Yes, they can produce more of it, but really what you can talk about in the future is you can put bigger versions, industrial size scale versions of this on the Martian atmosphere, or soil rather, to use the Martian atmosphere, and essentially then just have this producing in the background. You don't need a person there to make it. You don't need a person using it. Essentially can build up stores of oxygen to be used in the future. And that is going to be the key to space travels, not just to do it with humans doing it at the time, but to essentially build up reserves forward-looking.
Well, let's check in with Ingenuity now, the helicopter that flew last week. It's flown again for almost double the time and height.
That's right. So it's gone higher, it's gone further, and it's now had its third flight as well. They just keep going with Ingenuity. And really, this was always the whole trick, is once they nailed that first flight, as we had last week, it was always going to be a matter of, well, how long can we go for? How high can we go for? And just how much can we get out of this thing? Turning it from just a technology demonstrator, which was the primary mission of this, just to show it worked, to actually potentially providing some useful data for us, for Perseverance, and also for future flights on Mars.
Well, this second flight was more ambitious, not just higher and longer, but also slewing to the side and pitching the camera around the landscape of Jezero Crater.
Yeah, and it took a very beautiful panorama that we're starting to see the colored photos from these drone shots with. And I think that's the amazing thing, is that we're just seeing drone shots on Mars now. It is a bit out there, so to speak, to think about what we can do, but it is happening more and more. And it is going to keep doing it essentially until it can't do it anymore, until they run out of battery, it no longer has any juice left, or they reach the operational limits of this 1.8 kilo drone. And so it's remarkable now that we've gone from, hey, now just does it work, to we're taking out for some joyrides. They're taking out for a good spin around Mars.
Well, there are 3 more increasingly complex flights to come. The next flight will see it aim for 50 metres downrange and getting further and further away from there. And we'll talk about the last flight in a second, because that's going to be a sad end. But these increasingly complex flights, as you say, it was a technology test, and now they're going to see just how far they can push the technology.
That's exactly right. Already going 50 meters and going further, really pushing the bounds of distance. It also can't stray too far from Perseverance, and this is one of the limits, that Perseverance is reliant on the communication delay or relay for Ingenuity, as we talked about last week. So if it strays too far in this case, and say something happens to it, it won't be able to relay the data. So either Perseverance chases back after it, or you'll lose that valuable information. So there is a bit of a limit in the extremes to how far it can go, and they are pushing it, literally to the edge. They're Tom Cruising it in Top Gun. They're pushing the bound, so to speak.
Well, that last flight, talking about the limits, the engineers want to find where it is. It's likely going to end in a crash landing, which, as I said, is a bit sad, but the data gathered is very valuable, and we've got most of that back here on Earth now as well. And as we mentioned last week, this will pave the way for future missions, not just on Mars, and not just in the future. There's already missions planned for this technology to other parts of the solar system.
Yeah, and look, this is a good point, is you don't know where the ceiling is, literally, of flying until you hit it. And because it's a robotic mission, it's not like you can steer out of it. They know that it's going to be a ceremonious ending. But in other ways, otherwise, it just sits on the surface and just runs out of batteries, and then you just can't recharge it. So either it really goes in with a bang, so to speak, or it just kind of whimpers and fizzles. So they're going with the former, which I by far think is the correct choice for awesomeness. But also, as you said, it actually will provide data, as in they now know it is possible. So just where is the limit? How high can they go? And until you hit the limit, you don't know. So just keep going up and up and up, and at some point, it will stop and it will literally come crashing down. But that was always going to be the point. It was always going to end at some point. It was never going to keep on going. They were just hoping that it didn't end on the first flight, right? That's the thing, is there was a non-zero chance the first flight was the only and final flight of Ingenuity. So the fact that they'll get 5 out of this at the current rate is, I think, a remarkable feat of technology.
It absolutely is. Well, lastly, this week, Brad, we're hearing reports that the space junk map is tracking 200 ticking time bombs just days after Crew 2 had a close encounter of the debris kind on its way to the International Space Station.
Yeah, we've been talking a lot about the work happening in space junk area to clean it up with lasers or these refueling satellites. And this really just goes to show it is a risk. This is not something we're just saying, but it's a hypothetical. A map led by Mariba Jha out of University of Texas, and a good friend of mine, has been using his Astria graph maps to essentially try to figure out where are the really hazardous pieces. We know there's a ton, but where are the big ones? Where are they in terms of their position in orbit? Because if you're by yourself, you will be less of a risk than in a very crowded area or orbit. And how many are likely to produce those critical chain reactions? Because that's the worry, as ones break apart, crash in the others. And his team has found there's essentially 200 really hazardous pieces of space junk out there. And in the truest sense, there is no control. They're just flying around and pose a very real risk. And as you said, something that happened over the weekend with SpaceX Crew 2.
Well, the astrograph, it's a near real-time map of where each object is. And as we're saying here, it's becoming even more critical that we know exactly where these objects are and what they're potentially going to do.
Yeah, because it's all about timing and location. And while that sounds simple, it's not, right? You can figure out the orbit of an object, but the orbit can vary based on how long it takes, where in its position. When you're traveling 40,000 kilometers an hour, being off by 5 minutes is a pretty big difference in distance, right? You know, we're not talking about being off by 5 meters. We're talking about being off by tens of kilometers. So this really does matter in terms of knowing exactly where it is, because as in the case of SpaceX, if there is a potentially hazardous piece of debris, they have to prepare. And in fact, for those who are watching the stream of SpaceX saw, they had to re-get into their spacesuits because there was a worry, it was a false alarm, of a potentially hazardous piece of debris. And that is the protocol in space station, that they have to get into essentially their emergency capsule, their way home, because if things are about to go bust, so to speak, they need to get out of town. And this is always one of the limiting factors of humans. You will only have as many seats as you have humans. So you will always have a ride back down, like a lifeboat on a boat, because of this exact reason. If something goes wrong, and it's becoming a bigger and bigger and bigger problem. This is becoming, as we send more humans and things into space, and as we build up more space junk, you know, those two things are not conducive to a very safe space, so to speak.
Yeah, absolutely. Well, these 200 time bombs are classed as super spreaders. We know about super spreaders at the moment in the world, but these ones are in orbit, and rocket hulks is what they actually are, and they could break into thousands of pieces.
And that's exactly right. It is one big one can turn into thousands, which all can crash into their own, which can then break apart. And it really is that chain reaction, and that is the worry. We worry equally about the small ones. But we worry, you know, it's a scale of worry. A small one can do a lot of damage. It's very unlikely to produce more bits of debris other than disabling or destroying that one bit. Big things that can create more, which can create more. It's kind of like, which problem do you focus on first? But it does come back down to the point of this thing is, at least the easiest path forward right now, this isn't the best path forward, is at least know where they are so you can tell the things that you can control, like the space station, like SpaceX crew, to get out of the way. And that's the comparable thing. But it all goes back down to knowing where they are, their orbits, and what they're doing. And this is something Australia is becoming a big part of, what we call space situational awareness, essentially air traffic control for space. Where are things? Where are they headed? What are they doing? And where are they potentially going to collide into? Because if you don't have that information, none of the rest matters because you're out of luck.
Exactly right. Well, can Mount Stromlo's new laser aid in this work of astrograph to identify and hopefully lead to the elimination of these threats?
This is exactly the thing. In fact, Mariba is a visiting academic here at Mount Stromlo at ANU, working on trying to grow this thing to exactly expand this project now. And there was a workshop late last year about how do they grow it in a very efficient way on the small scale. So this is definitely the cutting edge of what we're trying to do to manage this growing problem of space.
All right, Brad, well, just before we go, a look ahead to this week's Talkin Science interview. Dr. Laura McCamish is my guest. She led an interdisciplinary research team to identify the spectral signatures of almost 1,000 atmospheric molecules may be involved in the production or consumption of phosphine, which, as we talked about a few weeks ago, is a key ingredient for life sign detection on exoplanets. Now, can you tell us what is phosphine?
So phosphine is a molecule that has a phosphorus atom linked with 3 hydrogen atoms. So it's one of the simplest phosphorus-containing molecules out there.
And that key building block was recently found when scientists were poring over the 1978 Pioneer mission data to Venus. Why was that announcement so controversial?
So I think they went back and found the data in 1978. The recent data was they found some spectral lines using microwave spectroscopy, looked in the atmosphere of Venus, and the reason it was so controversial is because phosphine just shouldn't exist in Venus's atmosphere without something weird going on.
And that interview is going to be out on Thursday at 12:30 p.m. GMT. Or, of course, if you're watching us in the future, it's going to be a card in the top right of the YouTube video and, of course, on the website at trekzone.org. Brad, great to pick apart the stories of the week with you. We'll do it again next week.
Keep up to date with Twitter. Catch new podcasts daily on YouTube. Plus, we're beaming to your favourite podcast app 5 days a week. Just search for Trekzone and subscribe.